Welcome students. We come back again with a new video that can give you enough knowledge and that will make you wise. Okay? So don't waste my time and your time also. So we repeat once again, read your chapter very much carefully. Okay? And watch my video to achieve your goals. This is your main target. So don't waste any time. Read always your chapter, do the numericals and give you 100%. Okay? So today we discuss about the part that is the electric field and electric intensity also. Okay? So last day we discussed about the Coulomb's law and the NCERT exercise solve. Now today we discuss about the electric field and the electric intensity. After that we move to the electric dipole. Then we again solve the numericals. Okay? So what is the first things? What is the electric field? Okay, so just we write electric field. What is electric field? Electric field, that means, consider electric field, that is a static electricity and magnet, never be always same like that. So consider we just take a positive charge, this one plus Q. Okay, this positive charge, it can be treated as a source charge. This one is called the source charge. When we place a source charge, surroundings of the system, that is, consider this one is the surrounding. So surrounding, there would be change. A change will be occur in this case. That is, some properties of the surrounding, it may be changed because it is positive. So it can produce the positive field surrounding of it at a certain range. This range, throughout which a certain range it may be occur, that is certain change it may be occur, it is called the electric field. So we just repeat once again. That is, we consider a plus Q charge. Just simple. Okay, this plus Q charge is placed at the center, and when we place a plus Q charge at the center, surrounding of it, there is a change in the properties. Properties, what is the means by properties? That means this is positive. So that means it gives some positive field surrounding of this. So when it is the positive field surrounding of it, that means if I just consider a plus 1 charge, okay, plus 1 coulomb, the charge is placed over there. So obviously positive repulse within the specific field, which is the specific volume. If it is cross the level field, that is, if 1 coulomb charge is placed at these positions, so repulsion force tends to 0. Okay, so repulsion force acted within a certain region. This region is called the electric field. Okay, so in one sentence we just say that is a positive charge placed at some points. When a positive charge placed at some points, it can change the properties of the surrounding. When it can change the properties of the surrounding, that means it can change, it can produce some forces. It may be attractive in nature, it may be repulsive in nature. If I place a plus 1 coulomb charge, that is force is repulsive in nature. If I place a minus 1 coulomb charge, it produces the attractive in nature. Okay, I think it is clear. Okay, so this is the electric field and it can produce in this case. Now we come back to the points, that is the electric intensity. Electric intensity, it is also called the electric strength. Electric strength or electric intensity. So what is the electric strength or electric intensity? We just recapitulate once again. That is, plus Q charge is placed over there. Surrounding of it, there is a change of properties occur. What is the change? This change is called the electric field. Within this electric field, if I place a unit charge, 1 coulomb charge, the repulsive force given, this repulsive force given, and this force is considered, this one is F. When the force in this case, that is F, and it is given on the charge Q, then what is the electric intensity in this case? That is force per unit charge. Okay, so this one we just specified with this part. Okay, so now we discuss in this case. So plus Q charge, this one is 1 coulomb is placed, so repulsive force occurred in this case. Okay, so now we want to calculate the electric strength or electric intensity. Okay, so consider this is in three-dimensional space. This one x-axis, this one y-axis, and this one is z-axis. Okay, a main charge that is called the source charge. It is placed at the positions. Consider this one is Q dash. Another charge that is Q0. Okay, this is called the source charge. It is placed at the positions of P. Okay, so distance between Q dash and Q0, it is denoted with the R. Consider with the positions vector, that is the vector R. Okay, so obviously this one is plus and this one is plus. What is the force between them? Obviously repulsive in nature. So that is, if the force is F, that is F force, F, this force obviously is a function of R. Okay, this force F, this is the function of R. In this case, the acted on the test charge Q0. Okay, so Q0 produce the force Fr. Okay, therefore what is the force per unit charge? That is, for unit charge the force is Fr by Q0. This is Fr by Q0, it is called the force per unit charge. This force per unit charge. Now here Q0 can be taken as a tends to 0. That is, if I write in this case, that is limit Q0 tends to 0, that is Fr by Q0, this one called the electric strength or electric intensity or electric strength, whatever you name it. So what is the meaning of that? Q0 tends to 0. Q0 is tends to 0. That means the value of the Q0 is always tends to 0 or 1. Now a question arises in your mind, that is why this is tends to 0. Consider this is the positive charge and a test charge is placed over there. Test charge has some value, specific value. Okay, so when a specific value, it gives some more force on the Q dash source charge. So when the force is maximum, so it can change the original configurations of this. So it can produce some force on the source charge. So source charge can move outwards directions, that can move in the outward directions, that can change the directions in this case also. So when it can change, that's why we can take the test charge as a very, very small, tends to 0. That can never change the original value or original positions of the source charge and the surrounding also. That is the electric field. So test charge is always considered tends to 0, that means plus 1 or tends to 0. That can never change the electric field. Okay, we consider in this case only. So we just write what is the electric field or electric field intensity. Obviously this one is force per unit charge. But force per unit charge, what is the condition in this case? So remember, very much thing easy. That is Q0 tends to 0. Q0, that is the test charge must be tends to 0. This one is the main criteria in this. Okay, so E equals to limit Q0 tends to 0 Fr by Q0. Okay, okay. Now again, we just want to tell now the SI units and dimension of electric intensity. Okay, we know about what is electric intensity, we know about the electric field. Now come back to the point, that is the SI units and dimension. So E equals to force per charge, force per unit charge. Clear? So if I write the SI unit, what is the SI unit of force? That is Newton. What is the charge? That is the coulomb. Okay, so that is, we may write in this case, that is electric field or electric field intensity, that is equals to Newton per coulomb. Okay, now if I multiply it with M in both sides, so this is comparatively SI units and dimension of E, that is the force Newton per coulomb, that is Newton into meter, okay, and coulomb into that is C into F, okay, Newton into meter. What is Newton meter in meter? That is Newton per coulomb, it is denoted with the Newton into meter, that is equals to joule per coulomb into, that means it may be written as joule C to the power minus 1 m to the power minus 1, this one. Okay, so this one is the main part, we can say that that is joule per coulomb per meter. Okay, now come back to the point, that is the dimension. What is the dimension? Dimension, or that is equals to force by charge. What is the dimension of force? That is ml t to the power minus 1. Sorry, ml t to the power minus 2. And what is q0? That is at. So if I write in this case, that is ml t to the power minus 3 into a, this one. Okay. So this one is the dimension and this one is the SI unit of it. Okay. So one mistake, that is a to the power minus 1, this one, okay, because a move upwards, so it will be written as a to the power minus 1. Okay. Okay. So the next one, that is the electric intensity due to a point charge. Okay. Two cases is present. First one, when the charge is situated at origin. Consider again, this is x-axis, this one y-axis, 3-dimensional platform. So test charge, first one, this is the source charge, q dash. Q dash is placed at the position's origin of the coordinate system. Another test charge is placed at the q0. Okay, what is a test charge? Just we discuss about that. This is very much less, that is tends to 0. Okay, so this one is positive, q dash it is also positive. So what is, though both are positive, what is the nature of the force? Repulsive. So repulsive force acting in which directions? In the outward direction. Okay, so this one we repeat once again, this one q dash means that is source charge, q dash placed at the origin, and q0 that is placed at the any other point p. Okay, this is called the test charge. So both are positive, so repulsive force acting in the outward direction, and this is denoted with the F in this case. Okay, so obviously both this charge body, this is repulsive force, and we know that this is obviously electrostatic force. So we just write in this case, that is the force F according to the Coulomb's law, that is 1 by 4 pi epsilon 0 q dash q0 by r square. Okay, q dash q0 by r square. Obviously there is a unit vector or positions vector in this case, so we may write over there, that is we consider this one is r cap. Okay, so q dash q0 by r square, this one r cap. So what is r cap? This is unit vector. Okay, now r cap denotes the direction of the force, that's why we can consider over there. So r cap, this one. So what is the electric intensity? Electric intensity, that is the force per charge in our unit charge. So that is F by q0. Here F, this one, okay, this is the Coulomb force. So 1 by 4 pi epsilon 0 q dash q0 by r square into r cap into 1 by q0. Okay, so q0 cancel out. So only part, that is 1 by 4 pi epsilon 0 q dash r square into r cap. Okay, so this one is the part, that is r cap is the unit vector. So unit vector, according to the chapter vector, we know that what is the unit vector? If I denote it r cap equals to vector r by mod value of r. Okay, so unit vector r cap equals to vector r by mod value of r, that you know from the class 11. So we just putting the value over there, r cap. So we just write here, that is 1 by 4 pi epsilon 0 or epsilon naught q dash by r square into r cap. R cap means that is vector r by mod r. Clear? So this is the value of the electric intensity. So now we write, this is the electric intensity, this one, r by r dash. So we write here, that is E equals to 1 by 4 pi epsilon 0 q dash by r square into r. This is the mod value, so multiplied with this. So this one is r cube into vector r. Okay. Now initially we considered this is the 3-dimensional. This is the 3D picture. So 3-dimensional space. So a vector r, it may be written in the form that is x I cap plus y j cap plus z k cap. That we know I j k becomes the unit vector along x direction, y direction and z direction. So this one is the value. Okay. So r square. What is the value of the r square? Taking the mod of it. So r square equals to x square plus y square plus z square. That means r equals to root over of this x square plus y square plus z square. Okay. But here require r cube. So what is the value of the r cube in this case? So r cube equals to x square plus y square plus z square power of 3 by 2. Okay. Am I right? Now putting this value here. So we write electric intensity equals to 1 by 4 pi epsilon 0 or epsilon naught q dash by r cube. R cube this one. So x square plus y square plus z square power of 3 by 2. Okay. And the vector r equals to this one. So x into I cap plus y into j cap plus z into k cap. Okay. So this is the total value. Now if I multiplied these terms with the x into I cap, this term with the y into j cap, this term into z into k cap, that can gives the components, that is x direction component of the electric intensity, y direction component of the electric intensity and the z direction component of the electric intensity. So we write in this case that is equals to ex into I cap plus ey into j cap plus ez into k cap. So ex, ey, ez, what is this? This is the components of the electric intensity along x, y, z directions. Okay, up to this clear? So we move to the next one. Okay, we come back again with the next case, that is when a charge is situated at anywhere. Before first case, the source charge is placed at the origin and the test charge is placed at any point. In this case, source charge and the test charge both are placed at the different positions. What is the meaning of that? The source charge is placed at the positions S. Okay, and the test charge, that is Q0, is placed at the positions P. So just check it out. Q dash, it is placed at different positions, any point. Okay, not that it is placed at the origin or in a fixed point. That is placed at any point. This one. Okay, at the point of S. And here Q0 is the test charge. Test charge is placed at the positions of P. Okay. Now the positions vector of the Q dash. Positions vector of the Q dash, that is equals to R dash. Okay. And positions vector of P, that is the Q0 of the test charge, that is equals to vector R. Okay. We just repeat once again. This one Q dash is the source charge. Positions vector of the source charge, that is equals to R dash, and positions vector of the P, that is the test charge, is the vector R. So both are positive. So repulsive force occur and the force directed along this direction, that is along the outward direction. So arrow sign given over there. Okay. Now according to the triangle's law of vector, we know that the triangle's law of vectors. So this one, just check it out. So if I consider this one is the origin, so here arrow sign given over there. This one OS, this one is SP. So OS plus SP equals to OP. Okay, so we write in this case according to the triangle's law of vector, that is OP equals to OS plus SP. Okay, so we want to find out the distance SP because we need it, that is the distance between the source charge and the test charge. This is the main reason. So what is the distance? That is equals to SP. So what is the value of SP? That is SP equals to OP minus OS. Okay, so this one, that is SP equals to OP minus OS. So what is the value of OP? OP, this one is equals to a vector R. And what is the value of OS? OS equals to vector R dash. So SP, that is equals to R minus R dash. So we write here in this case that is r minus r dash, that is represent the vector sp. Okay, now it is clear. Now again we come back to the point, that is the force between test charge and source charge. Obviously this is the charge body, so Coulomb's force is generated over there. Force is repulsive in nature, so that is F equals to, is a function of r generally positively, so that is equals to 1 by 4 pi epsilon naught q dash q0 by r square. Okay, here the r square means r minus r dash, because the distance between them, here the distance between them, that is the sp, that is equals to r minus r dash square into unit vector of this. Okay, so it may be written in the form that is r cube, so r cube into r minus r dash, this one is the vector. Okay, so this is the part in this case, so this is the value of the force. Now we find out the electric intensity again. Electric intensity equals to force by test charge, so this one is 1 by 4 pi epsilon naught q dash q0 by r minus r dash r cube vector r, this one is vector minus vector r dash into 1 by q0. Okay, again q0 cancel out. When q0 cancel out, we obtain that is 1 by 4 pi epsilon naught q dash by r minus r dash whole cube into vector r minus r dash. Okay, so this is the value of the electric intensity. So today's video we discuss about the part, that is the electric field strength, electric intensity. Okay, the SI unit and dimension. Okay, so in my next video I will discuss about the electric dipole and the different cases related to the electric dipole, the different cases, that is the field, two separate case, the field is uniform or non-uniform. We also discuss in this case. Okay, so keep watching my video, my channel also. Thank you.